Greetings from TMES Academy of Science and Commerce. Department of Physics presents the practicals. This video is basically for a quick revision for upcoming laboratory examination 2024. In this video, we're going to discuss about the resistance per unit length of the wire. The aim of this experiment is as follows. To determine the resistance per unit length of a given wire by plotting a graph of current versus potential difference. The principle behind this experiment is basically Ohm's law. When temperature and other physical conditions remains constant, the electric current flowing through a conductor is proportional to the potential difference across the ends of the conductor. The formula used in this experiment is as follows. The resistance of the wire R is equals to 1 by M, where M is the slope of the graph, that is I versus V. And capital R is the resistance of the wire. And the second formula is a resistance per unit length of the wire. Unit length represents the one unique quantity, that is R by L, where R is the resistance of the wire and L is the length of the experimental wire, which is 1 meter. The apparatus required for this experiment is as follows. First one is eliminator, that is battery eliminator, key, rheostat, milliammeter, voltmeter, and the resistance of wire. And first, the negative terminal of the battery is connected to key, and the key and other end of the key is connected to the rheostat, and the other end of the rheostat is connected to the positive terminal of the battery. The rheostat, that end of the rheostat is connected to the positive terminal of the milliammeter, and upper end of the rheostat is connected to the one end of the wire, and other end of the wire is connected to the negative terminal of the milliammeter. The voltmeter is connected parallelly to the wire. The same figure is as shown in circuit diagram. As we explained in earlier, that is the circuit diagram is as follows. Battery is connected to the rheostat, and rheostat is connected to the one end of key, and other end of the key is connected to negative of the battery, and so on. The observation, the length of the wire is always a 1 meter. Here see, as the potential difference across the wire is increases through rheostat, we see the increase in current. For corresponding volts, we note down the corresponding current. As we can see that as voltage is increases, the corresponding ammeter, that is current, is also increases. This all we note down in a tabular column. First, we note down for a constant volt, that is the 0.2, 0.4, 0.6, and so on. Corresponding volts, we note down the ammeter readings. And we plot a graph for I versus V. The scale is as shown in the figure. We plot a graph I versus V as like this, and we get a straight line. And also we take the slope of this line. We know that the resistance can be defined as, that is 1 by M, that is 1 by the slope, that is BC by AC. As we substitute the values, we get the resistance of a wire is approximately equal to 6.66 ohm. And the resistance per unit length of the wire is given by R by L. That is, we got the resistance as 6.66, and we know that the length is 1 meter. Therefore, resistance per unit length of the wire is 6.66 ohm per meter. Thank you, and all the very best for your examination.